We know that everything in the universe is composed of atoms, but not all atoms are the same. There are many different types of atoms called elements, each with a unique set of physical and chemical properties. Many elements are probably familiar to you. Oxygen and carbon, for example, are elements, and so is gold. Others may be less familiar, such as bismuth, xenon, and osmium. A particular element is identified by the number of protons in its atoms, and the number of protons in the nucleus of an atom is its atomic number, represented by the symbol Z. For example, helium has an atomic number of 2. That means that every helium atom has 2 protons. And here's another example: iron. Its atomic number is 26, so every iron atom has 26 protons. An element's atomic number can also tell us the number of electrons in a neutral atom of an element. Remember, equal and opposite charges cancel each other out. So, to be neutral, an atom must have an equal number of protons, which have a charge of 1 plus, and electrons, which have a charge of 1 minus. This means that our helium atom must have 2 electrons, and our iron atom must have 26 electrons. All of the known elements are organized according to their atomic numbers in the periodic table. The periodic table lists the elements in order of increasing atomic number as you go from left to right and from top to bottom. The elements are further organized into columns based on their properties. Elements in the same column tend to have similar physical and chemical properties. Every element is represented by a chemical symbol, a unique 1 or 2 letter abbreviation that appears below the element's atomic number on the periodic table. Many chemical symbols are based on the English name for an element. For example, the symbol for hydrogen is H, and the symbol for aluminum is Al. But some chemical symbols are based on the Latin name for the element. For example, the symbol for lead is Pb, which actually comes from its Latin name, plumbum. Notice that whenever the chemical symbol for an element has 2 letters, the second letter is written in lowercase. All of this information is contained inside of each element's box on the periodic table. For example, here's the box for the element nitrogen. At the top of the box is nitrogen's atomic number, which is 7. Remember that this is equal to the number of protons in each atom of nitrogen, as well as the number of electrons. Below that is nitrogen's chemical symbol, N, followed by its name. Often you'll also see another number listed at the bottom of an element's box, which has to do with atomic mass. We'll cover details about this in another video. What's neat about having all of this information in one place is that if we know one detail about an element, either its atomic number, chemical symbol, or a name, we can often use the periodic table to find out the other details. Let's take a look at a few examples. Say we have the element phosphorus. What is its atomic number and chemical symbol? Looking through the periodic table, we can find phosphorus and see that its atomic number is 15 and its chemical symbol is P. Let's do another example. Say we know the chemical symbol Hg. What is this element's name and how many protons does it have? Here is the symbol Hg on the periodic table. Its name is mercury and its atomic number is 80, so it has 80 protons. Let's review. The universe is made up of different types of atoms called elements, and these elements are organized by atomic number in the periodic table. So, the next time that you stare up at the starry sky, you know that everything out there is made up of elements.